Hello, this is a list of new nodes which we are going to discover along this lesson. Since we already know a lot of nodes, this time we will try to do something more complex and interesting. Okay, let's get started. Create a torus. Dive into it. Put a 200 for rows, 400 for columns. Let's create normals, as we are going to use them soon. We will store them in points. You can check the normals by pressing this icon. Okay, let's go on. Let's drop down the attribute VOP. Wire the geometry and dive into it. Now we will use a new node called dot product. This operator computes the dot product between two vectors. Look, in simple terms, when we have two normalized vectors that are parallel to each other and both are directed in the same direction, their dot product will be 1. In case when we have two normalized vectors that are parallel to each other but are directed in opposite directions, their dot product will be -1. In case when we have two normalized vectors that are perpendicular to each other, the dot product will be 0. In other cases, the dot product varies between -1 and 1. Now I want to demonstrate in practice what it looks like. First, let's split the viewport like this. Then, switch to the geometry spreadsheet. Let's dive in again. As the first vector, we connect the normals. For the second one, let's create a new vector directed up. Let's visualize the result of the dot product. From the color, it is clear that at the very top of the torus, the dot product is approaching 1 because the normals become parallel to the given vector and look in same direction. At the bottom of the torus, the dot product is approaching -1 because the normals become parallel to the given vector, but they are directed in opposite directions. When the normals become perpendicular to the given vector, the dot product tends to 0. Let's export the dot product as a new attribute and check the result in the geometry spreadsheet. Take a look, the maximum value is 1, minimum -1. Let's hide all attributes. Then display only this. That's it, we can move on. Now let's change the second vector direction along -y. As you noticed, we get the opposite result. Let's try one more direction. I want to show you an easy way to set any direction you like. Create a transform matrix. This node transforms an input position, normal, or vector by a matrix specified by the translate, rotate, and scale parameters. Now we can rotate this vector around any axis and get the desired direction. Okay, now I want to show you why we need normalized vectors. Since both vectors are normalized, let's change the length of the normals by multiplying some value. As you can see, now the result of the dot product is out of the range of -1 and 1. Now let's normalize the normals. This operator normalizes a vector. Here we go, the dot product is in the range -1 and 1. The same applies to the second vector, let's quickly check this case too. That's it, we can move on. Let's get rid of this extra node, we don't need it anymore. I want to rename the exported attribute. Call it mask1, later we're gonna use this mask. Now I want to edit this mask a bit. For that, let's create a turbulent noise. Give it a position. Let's visualize the noise 1D output. Change the noise type just to generate positive and negative values. Let's also increase the frequency. Look, we generate values in the negative and positive range. Okay, now I want to introduce a new node called sine. This operator returns -1 if the input is less than 0, otherwise it returns 1. If the input value is 0 exactly, 1 will be returned. Look, all negative values became -1, and all positive values became 1. It means now we have only two values, 1 and -1. To shift the mask in a positive or negative direction, we can simply add positive or negative values. Here we go, we control the amount of positive or negative values. I want to clamp this mask and get 0 instead of -1. Now we have only 0 and 1. Visualize the dot product. I want to get rid of the negative values of the dot product too. Let's clamp these values also. Okay, all negative values became 0. Now I want to multiply the result of dot product by the noise. Here we go, we have noise at the top, and at the bottom it disappears. We're gonna use this mask soon. Let's jump at the object level and give a name to this attribute VOP. Now let's create a scatter node and generate points on the torus. Let's change the point count. I think better to return the default, which is 1000. Disable relaxed iterations. Enable the density attribute and give a mask. Here we go, the mask controls the density of points, so in the areas where the mask is 0, we have no points. Okay, now I want to copy some geometry at these points. Let's use a tube. I want to adjust tube properties. Now let's connect tube to the copy node. Let's also template the torus geometry. As you can see, the tubes are directed along normals. To make sure, let's disable and enable the normals. Let's adjust tube settings to get a more interesting shape. Look, the tubes penetrate the torus. To solve this problem we have to move the tubes along the z-axis. To make them sit on the torus, we can copy the height value. Paste it here, then divide by 2. Now we can adjust the height. Let's also decrease the radius scale. Great, let's move on. Now I want to create one more attribute VOP. Wire to this line and name it a Pscale setup. Dive into it. Now I want to create a Pscale attribute and then start to manipulate it. First, let's create a bind export. Name it Pscale. Let's also bind the mask attribute which we recently created. We called it mask1. Connect mask to the Pscale. Looks not bad. Let's also add some randomization. In this time we will use a Gaussian random node. This operator generates a random number fitting a Gaussian distribution. Plug to it the pt_num. Let's write the result of the Gaussian random node as a new attribute and see what it looks like. I will name it ran test. Open the geometry spreadsheet window. Hide all attributes. Then check the ran test attribute. Take a look, the Gaussian random node generated the random values in the negative and positive range. The sigma parameter controls the length of the range in positive and negative directions. To squeeze the range we must reduce the sigma, and to stretch the range we must increase it. Now we can delete the bind export node. Let's create an add node. Wire to this line, then add random values. I also want to adjust the sigma parameter. In order to avoid a negative Pscale, which will cause us to get inverted normals, we can add a maximum node and exclude the negative values. For the second input, let's put some small value.